After the governing equations, let's take a look at the boundary conditions. That's the domain for the problem, as we saw. So the governing equations need to be solved in this domain, and we need to provide boundary conditions at the edges of the domain. This is the boundary where we have the flow coming in with uniform velocity. So the axial component of the velocity will set to 1 meter per second and the radial component to be 0. This is where the flow is leaving the domain at that boundary, and we set the pressure to be 1 atmosphere. This is the wall, and at the wall the flow sticks to the wall. This is, when viscosity is present, that's called the no-slip condition. So we'll set both components of the velocity to be 0 at the wall. And at the axis of symmetry, we set the radial derivatives to be of velocity and pressure to be 0, because there can be no variation of velocity and pressure in this direction, in the radial direction at the axis of symmetry. And also the velocity at the axis of symmetry has to be in the axial direction. So we set the radial component of the velocity to be 0. So those are the boundary conditions. And now that we know the governing equations and boundary conditions that we need to solve, let's take a look at how the tool, ANSYS Fluent, will solve it for us using a numerical solution procedure.